Hello, I'm gonna explain now how to design canopies and roof monitor from the box building automatic generation. So I have opened this file that is already filled with cranes and mezzanines, and after generating automatically all the file as a box building without any roof monitor and without any canopies. So I made this example. If I go to frame number 2, this was the building as generated by the BIM. And now I'm gonna enter a canopy, a roof monitor, and afterward a canopy. So the nodes as generated by GMatrix are the nodes 1, 2, 3, 4, 5, 6 that I can see on these drawings as 1, 2, 3, 4, 5, and 6. In order to start building my roof monitor, and which I'm going to show you the shape now here as an example, so I will need to create a roof monitor at the ridge line. Okay, so I have to start by creating node number 7, 8, 9, 10, 11, 12, and 13. And how to do that? So we have two sort of node creation, as we can see here. So I can create a node by entering the coordinate x and y and z. So this is the name of the coordinate, this is the x coordinate, and this is y, and by default the z will be taken as 0 in our case. So node number 7, as we can see here, I need to create it at the left rafter. The left rafter starts from node 2 to 3. As I can see here, RL, it starts from node 2 to 3. So I want to create a dynamic node at this rafter by creating node number 7. I'm going to write RL, right rafter left, at 16.25. So what GMatrix will do in this case, it will create the node number 7 at a distance from the starting point, which is 16.25, and it will allocate a node that is a part of the rafter left. Same thing, I'm going to create coordinate number 8. So because the right rafter, it starts from 4 to 3, as we can see here on in the text file, from 4 to 3. So I will create node number 8 from right rafter at 16.25, and then I can see here from this point to 16.25 I created node number 8, and then I created node number 7. After that I have to create node number 9, 10, 11, 12, and 13. By a simple calculation, we came to know what are the coordinates for 9, 10, 11, 12, and 13. Node number 9, 16.16 as coordinate x, y 12.5. Same thing for 10, 11, and 12. I think it's clear up to here. Coordinate number 13, it is in the middle of the building, directly at the ridge line at the x of 17.195 with a y of 12.6, and this of course has been considered as an example. Okay, node number 14 and 15 has been created to generate the canopy. I'll go to look here, I can see node number 14 and node number 15. Node number 14 is a part of the column left at the distance I took the example as 5 meters here, 14 column left at 5 meters from the start point, which is node number 1, as we can see here on the drawing. From node number 1, which is here, I'm going to create node number 14 at a distance of 5 meters, and then after that I will create node number 15 having the coordinate x minus 3 and elevation y 4.5. By this I have created the nodes to build my roof monitor and the canopy coordinates at frame number 2, of course, as we can see here. Now I have to build the members, because GMatrix allow me to freely give any name I want to any member. So I have called the roof monitor as RM1 from node number 7 to node number 9, RM2 from node number 8 to node number 10, and so same thing for RM3, RM4, RM5, and RM6. For each member, I have to define the type of section. Here in our case is tapered, 250 by 4, 250, 125 by 5, 125 by 5, and of course I have to write the syntax rest because I have only one member. So let's see what does it mean on the screen. We can see RM3, RM4, RM5, and RM6. For the canopy, I have called it Can1, and we created the member Can1 from node number 14 to node number 15. As we can see here, Can1 from node number 14 to node number 15. Now, and of course, same thing for the taper, the section, the properties, beta angle, CB value, LZ, LY top, and LY bottom. In case I want to, if I have some purlins here, so I have to say the distance spacing is 1.5 at the bottom. For RM, of course, 1.5 because of the spacing of the purlin. It's different than 1.5. It's only an example. And RM1 is 1.5. Okay. Now I have to start by adding the load on each member. So I go to the load case, dead load. By default, GMatrix has created CL, RL, RR, CR. I added RM3, RM4, RM5, and RM6. And I added the dead load as minus 1.0246 or 248. I can add here also as a dead load if I want to Can1. The roof live load to be taken here as minus 4.1724 after the calculation of GMatrix. So I'm going to add a live load for Can1, and the same live load will be considered on the cantilever or the canopy. Collateral load, if any, coming to the crane dead load, no, there's nothing to add here. Wind loads, so for the wind loads here, I have added, only as an example, the same live load on the roof to be on RM3 and RM4, RM5, RM6. Okay. Coming to the canopy, I just keep it as is, only as an example. And by this I have added the wind loads to the members that I have created, which are RM3, RM4, RM5, and RM6. Now, the load combination, if I need to make any changes, I can make it also on the text file. If I need to add any connection, let's say on cantilever can 1, of course I can do the same thing for RM1 and RM2, but it's only as an example. So because can 1 is coming from the node 14 to node 15, so I'm gonna put a connection here that will be at the start point of can 1. So I have to write can 1, the name of the member, at which distance, which is 0, or let's say 0.1 meters. I'm gonna add at the top 4M16, doesn't make a difference if it's minor, capital, lowercase or uppercase. 4M16, plate 16. I'm gonna make it extended from the top, extended from the bottom, properties A. By this, I have edited this file to accommodate the connection of the cantilever, of the canopy, excuse me, and the roof monitor, and this will be the structural drawing that represents what we have done here. Okay. Now, I can check the design, I can make auto design, I can make any modification I need to do here for the sections. Let us now take this out and check if I need to add any additional purlins. If the roof monitor is coming from the first grid to the end grid, then instead of making separate calculation, I can directly add the number of rows that I need to add for the purlins here from this edit. So let's see. The distance is almost approximately 4.6 meters, which means that I have 1 and 2 here, 1 and 2 there. Let's say I want to add 4 rows of purlins. On the purlins here I have 24 rows, so I need to add 4 more, and this number will become, the quantity here will become 28 instead of 24. By this, I have added automatically the number of purlins on the roof monitor. Let's make it run. And this will be the result coming. Based on the calculation of the purlins. So this the quantity of the purlins that I have added 4 quantities, so this will come automatically in my BOM. Okay, I have stopped, just cancelled the iteration. As for the cantilever or the canopy, so if the canopy is coming from the start point of the building to the end point, I can do the same for the number of purlins. Otherwise, I have to make the calculation of the purlins separately and add it to my BOM. So by this, we have added roof monitor and cantilever with a load by editing the file and by using the syntax text file, and finally whatever I have added here or edited here, it will come automatically into the bill of material.